A very good morning, students. In today's class, I'm going to explain about the Kirchhoff's laws. Kirchhoff is a scientist. He invented two laws. The first law is called KCL, Kirchhoff's current law. Second law is called KVL, Kirchhoff's voltage law. These two laws are very useful for solving a given electrical network. These laws are useful for solving a given electrical network, and these laws are applicable for both AC and DC circuits. If the input is having AC or DC, we can apply KCL and KVL, Kirchhoff's current law and Kirchhoff's voltage law. First, we'll discuss in detail about KCL. KCL. The full form of KCL is Kirchhoff's current law. Current law. Kirchhoff's current law, KCL. KCL must be always apply only for junction. KCL must be applied only for junction. What is the statement of KCL? The sum of entering currents in a junction is equal to sum of currents leaving the junction. This is the statement of KCL. KCL statement. The sum of currents entering the junction is equal to sum of currents leaving the junction, or the algebraic sum of currents at a junction is equal to 0. The algebraic sum of currents at a junction is equal to 0. These are the two statements of Kirchhoff laws. Anyway, you can mention. The sum of entering currents in a junction is equal to sum of currents leaving the junction, or the algebraic sum of currents at a junction is equal to 0. How to apply KCL for an electronic circuit? So suppose take one point. This is the point A. For this point A, the current I1 is entering because the direction is entering here, I1. Okay. So next take another current. So this one, second current. This is going away from A. So this is I2. See the arrow mark going away from A. So this is I2, and take another current. So this is also entering towards the point A. This is I3. Okay, I3 is also entering. Arrow mark shows the direction of the current. Direction of the current shown by the arrow mark. Again, one more current. This is I4. I4 is also going out or away from point A. So at point A, 4 currents are there. The 4 currents are I1, I2, I3, I4. Out of all the 4 currents, here I1 current is coming towards the point A. So this is entering current, and I3 is also entering at point A, so it is also entering current. I2 is going away from A, so this is the leaving current, and I4 is also going away from point A, so this is also called as a leaving current. So out of 4 currents, 2 currents are entering and 2 currents are leaving. Then how to write the statement of KCL? The sum of entering currents is equal to sum of leaving currents at a junction. Sum of entering currents in a junction is equal to sum of leaving currents. Sum of currents leaving the junction is equal to, both are equal. Sum of currents entering is equal to sum of current leaving. So what are the currents are entering here? I1, I3. So sum of currents I1 plus I3 is equal to, what are the leaving currents? I2 and I4. So I1 plus I3 is equal to I2 plus I4. These two are the leaving currents. Or you can write I1 plus I3 minus I2 minus I4 is equal to 0. So this is the second statement, the algebraic sum of currents. Algebraic sum. Algebraic sum is having a combination of both positive and negative. The algebraic sum of currents at a junction is equal to 0. So I1 plus I3 minus I2 minus I4 is equal to 0. So this is two ways we can represent. So entering current is always taken as a positive and leaving current is always taken as a negative. So I1 plus I3 is equal to I2 plus I4. Like this we can apply KCL at a point or node or junction. Now I'm taking one electronic circuit. So take the circuit here. 3 resistors are connected, R1, R2, R3, and 2 power supplies are applied here. This is the positive. So the voltage value is V1 and second voltage is connected here. So the second voltage is V2 is the voltage. Two voltages are there, V1 and V2. V1 is, this is called as A, B, C, D, A. Give some points at each junction. A, B, C, D, A. This is called as mesh 1 and B, D. So already D we mentioned, no? So take another point. So A, B, C, D. So E, F. Okay. So mesh 2. This is called as a mesh 2. Second mesh. B, E, F, C, B. Second mesh. Mesh 1 and mesh 2. Two meshes are there in this circuit. Then how to show the current directions in the mesh? So current starting from the, we are assuming current will start from the positive terminal of the battery. So in the DC battery, this is the DC battery symbol. The long line representing positive and the small one is negative. Current start from the positive terminal of the battery. So current is coming from the positive. This current is called as a I1. Again, current is coming from the positive in the second mesh. So in the second mesh, current coming from the positive terminal of the battery. So this current is called as I2. So coming from the positive. So from the positive terminal, this is positive and this is negative, V2. From V2, second current is coming I2. So I1 is entering at point B and I2 is also entering at point B. So the two entering currents are I1, I2, and the leaving current is going from B to C. So this leaving current is called as I3. So three currents are there. I1, I2, I3. I1 current is coming from power supply V1 and I2 current is coming from V2. I1, I2 both currents are entering at point B and I3 current is leaving. Okay, so current entering terminal, current entering terminal, terminal of a resistor is taken as positive, and the current leaving terminal and the current leaving terminal is taken as is taken as negative. That means current is having a direction, whether it is a positive or negative. Current entering terminal is taken as a positive and current leaving terminal is taken as negative. Now see how to apply the polarity. Current is entering here, so this is positive, this end, and current is leaving from R1, so this is negative, positive and negative. Again, current is entering from resistor R2 through I2. So this end is positive and this one is negative. Again, current is entering in this path. So this is positive and this one is negative. Current entering terminal is positive and current leaving terminal is negative. So these are the directions of the currents in the circuit. So three currents are there, I1, I2 and I3. Then how can I write the KCL at point B? What is the statement of KCL? Apply KCL at point B. Apply KCL at point B. So the sum of entering currents is equal to sum of leaving currents. How many currents are entering? Two currents, I1, I2. Sum of entering currents. So I1 plus I2 is equal to sum of leaving currents. How many currents are leaving? Only one current, that is I3. So what is the equation? I1 plus I2 is equal to I3. Sum of entering currents at point B, I1 plus I2 is equal to leaving current I3. So I1 plus I2 is equal to I3. So this is the statement of KCL. Like this KCL we can apply for any electronic circuit. Okay. So what is the statement of KCL? The sum of entering currents is equal to sum of leaving currents in a junction, or the algebraic sum of currents at a junction is equal to 0. This is the statement of KCL. So if we take one electronic circuit, so we are assuming four currents here, I1, I2, I3, I4. The entering currents are I1, I3 and the leaving currents are I2, I4. So I1 plus I3 is equal to I2 plus I4. Sum of entering currents is equal to sum of leaving currents. Or we can write I1 plus I3 minus I2 minus I4 is equal to 0. The algebraic sum of currents at a junction is equal to 0. So in next class, we learn how to apply KVL, Kirchhoff's voltage law, for an electronic circuit. Thank you.